Hello. Okay, so this video is part 2 of your condensed sig fig lesson, significant figures. We figured out that in science numbers, our numbers are showing both the quantity and the level of precision of the tool that we originally used. And I think our next step is to get into kind of linking these things together. So we started with the word significant figures. We've been talking about level of confidence of your tool. And let's just merge those together. When you say how much confidence do you have in your measurement, another way to kind of say that is how many significant figures can you measure to? So like how much confidence in the measurement that clearly how much confidence do you have in your measurement is referencing the tool that you're using. How much can you see in that tool? Another way to say that same question as here's your link to the sig figs. How much confidence do you have in your measurement is the same thing as how many sig figs are in your measurement. And in the original longer videos, we went into measuring a room with a ball of yarn versus with a fancy laser tool. One tool is just going to give you a more precise number that you have more confidence in, and one gives you a lower level of confidence. When you're looking at your numbers, you can ask the same question by saying how many significant figures, how many significant place values could that tool measure to? Here you've got a tool that could measure, and we can actually count them. This tool could measure 1, 2, 3, 4, 5, 6 place values with confidence. Okay, so we would say this number has 6 significant figures because it has 6 place values that tool could confidently see and measure. And you can rewind that. This is a condensed version. But this number has 6 significant figures because the measuring tool could see 6 place values with confidence. This number is less confident. You can see that already. This number has 2 significant figures. Only 2 place values we could measure with confidence with that tool. Now, you're probably scratching your head because there are 3 numbers written there, and we're going to use that as our bridge to the question of what are the significant figures, because some figures are just numbers. Some numbers show that you have confidence in that place value. Other numbers, great, are a little trickier. Let's just translate that sound to a little trickier. Let's give you down here. So, okay, so we're looking at a question, how many significant figures are in the measurement? It begs the question, what are the significant figures? What are the significant figures? Okay, off we go. These numbers are always significant. always significant. Cool. That makes sense. If we are writing down 1, 2, 3, 4, 5, 6, 7, 8, or 9, that means that our tool could see that measurement. Those numbers are always significant. You will notice a number is missing. Zeros get an entire heading to themselves because this is where it gets complicated. There are 3 types of zeros. Middle zeros are zeros in the middle of a number. So for example, that is a middle zero because it is in between 2 significant figures. The 1 we can measure, the 3 we can measure, therefore the 0 we can also measure. Zeros in the middle of a number are always significant. Those zeros are also significant. They are in between significant numbers. Middle zeros are also always significant. I'm gonna keep this a little organized. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9 are always significant. There are 3 types of zeros. Middle zeros are always significant. Beginning zeros are zeros at the beginning of the number. So those are beginning zeros. Those are beginning zeros. Any number at the beginning of the number, no, any zero at the beginning of the number is never significant. This is the condensed version, but in short, if you know that you have 32 of something, and that's all you're writing down is your measurement, you can be totally confident that there are no thousands, there's no millions, it's only 32. You would have been able to see and therefore mention if there was also a million of that thing. Therefore, even though we have total confidence that those are zeros, they don't add to our understanding of the quantity, like they don't add to our measurement. So beginning zeros are never significant. Middle zeros, beginning zeros, and ending zeros. Ending zeros come at the end of a number, and whether they are significant or not significant completely depends on if you write a decimal place. This is another super just odd feeling thing, because in math class 200 and 200 are the same number. Not so much anymore. If you write the decimal with a trailing decimal, that decimal means, like, it is definitionally, it means, it defines as, this is significant. So because of that decimal, this number has 3 significant figures. Because both of those zeros are significant, we know because we bothered to write the decimal. If we don't bother to write the decimal, here there's no decimal, no trailing decimal. With no trailing decimal, these zeros are not significant. Okay, I'm going to zoom in on all of that. This is your ending zeros. If there is a decimal printed, what that means is we could see to that level of precision. So we are completely confident that measurement is 200 and not 201. We're totally confident it is exactly 200. It is not 199. Like, we know with great confidence it is exactly 200. To show that, we write that trailing decimal. Over here, we did not write a trailing decimal. There's no trailing decimal in this picture. It's 200 with no decimal. That means it's about 200-ish, but like, we're not totally sure. It's close. I mean, like, we have a significant figure in the hundreds place. We can see with confidence it's about 200, but we're not even really sure if it's maybe, this could be 210. We don't know. Our tool can't say. This is like measuring with a ball of yarn. You get a kind of approximate number, but like, we're really not super confident in exactly what that number is because our tool can't show us. We don't have a fancy enough tool to be confident in those zeros. Okay. Rewind again if that's not making sense. I'm gonna go on for the condensed version. And we're into our examples.